So pi r squared, radius of 1 squared is 1 pi. All right. That's all we're going to do with all of these. So the second one, you're going to do 2 times pi times your radius. So the circumference, again, that's the length around a circle. How many steps would you need to take to go around a circle is 4 pi, which is about 12 steps. If we want the area, you're going to do pi r squared. You're told what r is. So 2 squared is 4. And then you're going to multiply that by a pi. Okay, finish those off. None of this is difficult. Next one, you're going to use a radius of 3 to get the circumference and the area. Last row is going to be 4, so let all of your r's be a 4. Okay, well, there's a couple things we can then kind of see. There's one big one that we want to share down here. But if we look at this here, if we revisit our Math 1 days, notice how we're increasing by 2, increase by 2, increase by 2 right here. When we increase by the same number over and over and over and over again, you remember how you would call this a common difference? Okay, for your Math 1 days, that's linear. All right, linear implies you have a degree of 1. All right, that's one thing we kind of want to understand because this is a degree of 1. It's linear. You have that common difference throughout. 2, 4, 6, 8 increases by a 2. All right, if you look at this, this is not linear because you have a power of 2. So now let's see if this follows any pattern. This would increase by 3. This one increases by 5. This one increases by 7. So is there a common difference throughout? No. You also dealt last year with something called geometric series or function. That increased by a common ratio. So in this case, don't write this down because this won't be right. My ratio would be 4. 1 times 4 would give me this 4. But if I multiply 4 by 4 again, does that give me a 9? No. So the little pattern that we want to see here, this is what we actually started the beginning of this year off with, long time ago. Remember how these were quadratics? They gave us parabolas, that sort of a thing. Watch the pattern that's going to form here. This guy increased by 3. This one increased by 5. And then this one increased by a 7. So are they increasing by the exact same thing? No. However, if you look off to the right here, this is what we would call our first difference. And our second difference, didn't our second difference increase by 2? The one after that one increased by a 2. So a quadratic doesn't have a common difference like a linear one does, like the circumference, but the second difference would be common. All right, that second difference is always going to be a 2. All right, so those are the things we want to talk about a little bit. It's just a little review. Linear versus a quadratic, really old ideas. What we want to kind of put together now with our area and circumference that we've been doing recently is a ratio. So if I ask you to find the ratio, I'm going to write it like this. Give me the ratio of the area of a circle to the circumference. All right, remember what ratio is. Let's maybe as a quick refresher. Let's go to 2. If I ask you to do this, and we'll come back and see if you understood what I'm asking with this. If I ask you to, so this will all be different for everybody, the ratio of bathrooms to bedrooms in your house. All right, so for me, a ratio is a comparison of two numbers, usually by a fraction. We could also do the little colon, but usually by a fraction. So for me, I have 3 bedrooms in my house, and I have bathrooms, and I have 4 bedrooms in the house. That's our ratio. You're comparing one to the other. And in this case, we wanted bathrooms on top, bedrooms on the bottom. All right, so that next one, if I said the ratio of adults to children in your house, so for me, I had 2 adults, let's do it as a fraction, and I have 2 children. All right, so for me, this is a 1-to-1. So for you guys, it's obviously going to be a little bit different. All right, so do 4 and 5, and then we're going to revisit the one that we're ultimately concerned about up here. So do televisions to the people, and then people to phones. All right, number 4, we'll get a little insight into the house of the Briscoe family. So Ella, how many televisions in the Briscoe house? 6. Oh, and how many people? 5. Okay, it's pretty close. So 6 to 5. So 6 televisions and then 5 people. All right. Julia, you and Nick. I know you and Nick. How many other people are in your house? What is it? All right, so 3 people, and then how many cell phones? Oh, you have another sibling? Older or younger? Oh, geez, she's old. All right, people in your house. 5, and then cell phones. Yeah, I would imagine for a lot of you, this is a 1-to-1 relationship right there. Okay, but that's our ratio. So what I want you to now do, the same idea. That's a ratio. This is something we dealt with a lot at the beginning of the semester. Do it with the area of a circle to the circumference of a circle, and see what you come up with. Okay, can anybody give me a ratio they use here? Because there's a bunch of different ways you can go about this with what you currently see on the paper. Anybody? Armando? What'd you simplify? What did you do? Okay, so he did 16 pi divided by 8 pi. So when he set his ratio up, he used this row right here. The 16 pi is the area on top, and then the circumference on the bottom. And then he asked, do we just want to simplify that? So let's go ahead and simplify that. When we simplify that, area to our circumference is the pi's would cancel. This is really just a 2-to-1 relationship in this case. All right. However, let's say we did the next one. So let's say we would have done the exact same thing, the 9 pi over the 6 pi. That is, again, area over circumference, just as Armando did. These will cancel, and our area compared to our circumference ends up being now 3 over 2. All right, what is 3 over 2? If I did 3 divided by 2, just so we have a nice number here, because we have a nice number right here. Do we agree that's 1.5, 3 divided by 2? All right, let's do one more. So let's do our next row. It was 4 pi to 4 pi. So the area was 4 pi. The circumference also nicely ended up being a 4 pi. That is a 1-to-1 relationship. So if I just did that, does there appear to be a relationship in any of these? Is it the same ratio in all of them? No, we get 2, we get 1.5, we get a 1. All right. However, let's say we did this. If I'm going to do area over circumference, can't we use the formulas? Area is pi r squared. The circumference is 2 times pi times r. Pi divided by pi would cancel. Here's what this ratio should have ended up being. I don't remember if we do this or not. R squared, I don't know if it's a math 1 or a math 2 thing. If I had r squared divided by r, which is what we have left over, That means one set of r's are going to cancel. What I am left with is an r on top. So I am left, when I reduce this, to an r divided by a 2. So what should be our common ratio in every one is I should have been able to take my radius and then divide that by 2 and get the same exact thing that we got here. So look at this row that Armando used. If I took the radius and I divided it by 2, did I get the ratio in Armando's that we were supposed to get? Yeah, we got 4 divided by 2, which is a 2. Then we did the 6. All right. And then the 9 pi. Well, look at that radius. That was a 3. If I put a 3 right here, don't I get 3 divided by a 2? That's what we ended up with that second row. Okay. So the big one that we want to understand out of this, because then we can kind of use this to answer some questions, is that when we do a comparison of our area to our circumference, we could just take the radius, cut it in half, and then that's the ratio between those two values. Okay. If Armando had given me this, which also would have been completely fair, then we would have ended up with the 2 on top and then the radius on your bottom if we just flipped everything. Okay. So that's something we want to kind of know. All right, and that's why we then kind of went with these ratios to kind of do that same exact thing. So now go to this next problem. And we now have a couple of different ways we could answer this. And these are the ones that we kind of want to be able to get to, just rehashing what we've done the last couple of days, a little more involved. It says, use the given information to find the following. So now, let's say I told you the area of the circle is 25 pi. So before I do it, this is very much something that you will see in the future. Standardized tests on our quiz Friday. Tell me what the circumference of the circle would have to be. Can we think that through? So if we know the area, how could we figure out the circumference? All right, let's see where we're at here. I want to know the circumference. So you did this yesterday, the entire period with Mr. Kubowitz. We were then just finding a sector of it, but we should definitely have that formula down by now. That's the circumference of a circle. What we need is the radius. Do I give you the radius here? No, but we should be able to figure that out. If I gave you the area is 25 pi, what would this radius need to be? Be confident in that, knowing what that is. Armando? Good. That radius would need to be 5. And how did you know that, Armando? Good. I like both of those. So the area of a circle, there's 2 different routes you could take here. The area of any circle is pi r squared. You know the area is 25 pi. So initially, it sounded like he just kind of thought backwards. Eraser to work. And in some of them, especially this one, this is a nice one that if you just thought backwards, you could probably do it in your head. We knew the area here was 25 pi. So all you're really thinking of is what value of r, it's a little delayed today here. What value of r would you square here to get a 25, and wouldn't that be a 5? So that's one way. Just kind of think backwards. They won't all be that nice. They won't all be perfect squares. So then that's why I kind of liked what he said next. Let's say I asked you to solve this equation. We would divide by pi. We're trying to get that r by itself, so those are going to cancel. And then the second thing that he said is he took a square root. Because if I have this equation right here, I get rid of squares with square roots, and the square root of 25 is a 5. That's then what we plug in over here to be able to figure out what our circumference is. Okay, so our circumference would be 10 pi. We're dealing with centimeters, so that would be the circumference of that circle. Okay. 7 is the exact opposite. Now I'm giving you the circumference of the circle, and I want you to find the area of the circle. So whatever we're looking for, that's kind of what I would start out with. The area of a circle is pi r squared. In order to answer this question, we need to know the radius. That's the missing piece of information there. Instead of just giving you the radius like you've been given here yesterday, the day before, you're just given now the circumference. And based upon this piece of information, we should be able to figure out what our radius is. All right. So now it's the exact opposite. Now we're going to use the circumference formula. And we want to figure out what our r is. And I am telling you that your circumference is 10 pi feet. Solve that little equation. So in this case, we want to divide by the 2 pi. These will cancel. Pi's will cancel. And then this is the one that we just did right here. So we can kind of see whichever way we start. We should be able to work backwards. And then doesn't that give us the 25 pi for our area? All right. That's a 5. Kind of looks like an 8. Okay. All right. So real quick, last two of these guys. Again, doing the exact opposite of what we did yesterday. All right. So largely the same thing that you did yesterday. Homeworks, people seem to be confident in those. But now I am telling you the area of the sector. Yesterday you were finding the area of the sector. And I want you to tell me what the radius would now be. Okay, so now it's working backwards off of what you did over and over and over again yesterday, what you would have done on that homework. All right, we want to figure out sort of now what is the radius of this circle. All right, so as a quick drawing, and you don't necessarily have to draw these out, but I would suggest drawing them. So let's just say we drew this in. There's our circle. I have a central angle at 72 degrees. So I'm going to start my angle right here. And then we would all know that a 90-degree angle would be right here. So I'm going to dot that in because that's not what we want. If I want a 72-degree angle, that means it needs to be a little bit smaller. So we'll draw that guy in right here. So what I am telling you is two things. We know this angle is 72 degrees. And we know the area now, because yesterday your goal in all of those problems was to actually find the area of the sector. Now I'm giving you that. And if you're given that, how could we now figure out what our radius is? Okay, so we're just working backwards. All right, so we are looking for this guy right here. What's our R? All right, so it's going to still deal with this idea of the area of a circle. So let's first identify the area of a circle. We should all have down pat at this point as pi r squared. Well, what we have now, we don't have the full circle. What we want to figure out is what portion of the circle are we dealing with? So similar to what you would have done yesterday, we're going to take that 72-degree angle and we're going to compare it to the full 360-degree angle. Right? And then again, hopefully you have a way to do this on your calculator. This, I think, is the most efficient. So if we did 72, divide that by the 360, what this will tell you is we have 1/5 of the circle. All right, so 1/5. Oops. Okay. Of that full circle is equal to 20 pi. Okay, so we could have 5 more pieces of pi like this. I don't know if I can sketch this in perfectly. 1, 2, 3, 4, 5. Perfect. We would have 5 of those. Solve that now. See what we think here. See if we could now figure that. There's a couple different routes we could take. Some of it is just kind of number sense, working our way through. We have 5 of these total. That's what we just found here because I have one of the total amount of 5. So we're looking for these other 4. What would the radius be to make this true? And see if we can rationalize that out. There's a couple different routes we could take here. Anybody? All right, Mo, what'd you do, Mo?
I put 10.
And how'd you get that?
I divided by 20 by 2 to get 5.
Let's say that one more time now.
I divided 20 by 2 to get 5.
You took 20, divided it by 2.
Yeah. To put it.
Okay, so his answer is right. So if you got 10, correct. Right? So let's kind of make sure we kind of understand that reasoning there. That's okay. A little bit. Okay, Armando, what'd you do?
Well, I started with your equation, so what I did was divided by pi on both sides so it can cancel out.
Okay.
And then given the fraction, I multiplied by 5.
Okay, so at this step right here, he did this kind of from an algebra perspective. If we're trying to solve R right here, we want to get rid of that 1/5. So since we're technically multiplying by or dividing by 5, he multiplied by 5 to get rid of that 1/5. What that would leave us with then, whatever you do to one side of an equation, you've got to do to the other. It's a good time for my pen to break. Come on, you. So I've got to multiply this side by 5 as well, and that's 100 pi. All right, what's that then lead you to, Armando?
And then divide both sides by pi.
Good.
Cancel out the pi.
We can divide by the pi since it was being multiplied by the r squared. So then these cancel over there. And then how do we get rid of a square?
Square root.
Good. And then you do the square root, and your r ends up being a 10. So that's the pure algebra way. The other way is, aren't all of these 20 pi? Once I know one of them is 20 pi and I had 5 of them, then it's like the ones on the front page. The area of the circle is pi r squared. Don't we have 5 20 pi's? So we could, it's kind of the same process here. Don't we know the full area of that circle is 100 pi? And then we can solve the equation that way. The pi's would cancel, square root should get 100. Okay? Okay, real quick, number 9. An arc has a 120 degrees, has a length of 16 pi. So 120 is going to look like this. They are now giving you the length. The length of the circle is 16 pi. So you need to know that this is your circumference. All right, here's the circumference of the entire circle. What we need to understand is we don't have the entire circle. We have 120 of the full 360. And when we only have that much of it, that gave us a length of 16 pi. Okay? Solve that. We're rushing a little bit here. We would want to reduce this again. I would reduce it on the calculator if you're not good at reducing a fraction. That is 1/3. And again, there's some different routes you could take here. I'll do the algebra way. Multiply by 3 to get rid of that 1/3. Multiply the other side by 3 so that we get 48 pi. And then to get rid of 2 pi, you would divide. Pi's would cancel. The 2's are going to cancel. On the other side, the pi's cancel. And our radius ends up being 24. All right. Okay, no homework on this. I'll throw a few of these on the review. We're going to review again tomorrow for a quiz, and then Friday we're going to take a legit pencil and paper quiz, okay, over everything. And the bell has rung, if there was a bell, okay? I know, that's what I'm saying, like, go. Yeah. How'd you feel yesterday, Lily?